Hello everyone, hope you are doing well. Welcome to the online platform Civil Techno Bricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today, we will go through the core concepts related to the foundation of rock mechanics in the view of civil engineering. Rock mechanics studies the physical properties of various types of rocks, their behavior with reference to the stresses which occurred or applied on it, which is more essential for safe civil engineering design purposes. So, here rock strength and the rock mass behavior both intact each other, where it can be utilized to evaluate natural rock masses with reference to geological components like joints, faults, and folds. Means the lithostatic pressure influences rock deformation and which affects the engineering characteristics of subsurface rock formations, which are explained in the image 1, where the shear frictions are applied with reference to the lithostatic pressure in orange color and blue color likewise. So with reference to civil engineering, structural discontinuities often control foundation stability and tunnel performances, slope safety more than the laboratory rock strength or laboratory testing. So intact rock strength by using some compressive testing, where mass rock behavior which is naturally as explained in the picture. So rock mechanics deals with the physical properties of rocks and the significance of these properties in rock deformation and engineering projects. Here the structural viability on the basis of ideal building stone, where the properties are the compressive strength, structural massiveness, fracture healing and tensile strength. On the other hand, there will be a ideal trait and failure risk, two most important comparative structures, or we can say that the points, where an ideal building stone should possess its high compressive strength to safely withstand or bear the structural loads without crushing. Means the massive unjointed thick rock beds provide better engineering performance than highly fractured or thin bedded rocks. These rocks with good fracture healing or recrystallization characteristics generally exhibit improved long-term durability, where most important point is the tensile strength of rocks, which is usually very low as compared to the compressive strength, which making them vulnerable to track development under the various tension activities. So as explained, which is in the descriptive format, on the basis of some properties, the structural viability of ideal building stone with reference to its characteristics like brittleness, hardness, strength, crystallization, and many more. The next one will be the construction taxonomy, where the translating origins of the rocks towards the application of it, where the three types are explained: igneous rock, sedimentary rock, and metamorphic rock. Igneous rocks are formed by the cooling magma procedure. Sedimentary rocks are formed with reference to the compacted particles or sediments, whereas the metamorphic rocks are formed with reference to the external impact of heat and pressure. The example for igneous rock is the granite, which is most useful for the pier of any type of bridge, where limestone, which is useful for the building construction, where slate, which is a metamorphic type of rock, which is useful for the paver blocks, or we can say that the roofing purposes. Here the petrology classifies into three types, where granite, limestone and slate type of rocks are explained with reference to its importances. Likewise, the granite provide isotropic strength and excellent performance for foundations and heavy structures. Limestone, which is valued for its workability, uniform bedding and use in the cement production. At the last, the slate, which possesses planar cleavage, making it suitable for roofing, flooring, and architectural application purposes. Owing towards the withstanding dynamic loads in highway pavement. So, highway pavements are subjected to continuous dynamic loads or moving loads from moving vehicles and environmental impacts or effects. Likewise, n number of layers are constructed for the flexible type of pavements in a highway construction. The problem is that road faces constant localized dynamic impacts. So we have to sustain that impacts. The solution is aggregates must resist crushing under thousands of tons of daily axial weight while resisting the weathering effects of trap moisture. Means water impact is also most important point. So crushed basalt and trap rocks are preferred because of their high toughness and abrasion resistance characteristics. Strong aggregates prevent crushing, rutting and deformation under repeated traffic loading, whereas these are properly selected rock aggregates improves the pavement quality, durability, drainage performance and service life. Next one will be the hydrostatic pressure, that is shear strength in the dam foundation. Means we have to compare the hydrostatic pressure versus shear strength with reference to the dam construction point of view. So as the diagram explains, hydrostatic pressure which is acting in horizontal direction towards the dam of the wall by the stored water in the upstream side. At the same time, below to the dam of the wall, there will be a danger zone 1, danger zone 2, which is in orange color, where the shear strength is applying the forces with reference to the horizontal joints. They are closely spaced joints, allow water seepage and foundation slip. At the same time, the incline faults also most important to consider, that is a large joint dipping into a cut, which is the site of potential landslide failure. So dam foundations must resist both type of hydrostatic pressure as well as the shear forces acting on the rock masses. They are closely spaced horizontal joints which can increase seepage and reduce foundation stability, that is horizontal joints, whereas inclined faults or weaker planes may be cause or may become potential failure surface leading to landslides or any foundation settlement or movement. So petrological and structural point of view, we have to investigate each and everything so that it will be essential before selecting the site selection of any type of dam or foundation of any structure. The, owing towards the aggregates, the structural skeleton of concrete, where the two parts optimum bond and the failure risk. The aggregates which form the primary load bearing framework of concrete, while cement acts mainly as the binding material. Angular crush granite, these are the aggregates which provide better interlocking and resistance to shear failure, where well graded aggregates improve concrete strength, stability, and durability. So, here the aggregates must remain chemically inert within the alkaline cement environment to prevent long term deterioration. So, the optimal and risk. So, optimal, which is the angular well graded crush granite or aggregates that provide geometric friction to prevent shear failure, whereas the risk for that failure risk within with reference to the aggregate, that is the reactive solutions permitting pore spaces where aggregates must be chemically inert to highly alkaline cement like. So rocks acts as the critical load bearing skeleton where the cement is the glue, or we can say that the paste. Next one will be the industrial big three: granite, basalt and limestone rocks. So three types of rocks are considered, where high strength granite, extreme, that is basalt, and moderate, that is the limestone. So what is the profile for granite? That is a massive unjointed highly isotropic, which is useful for construction of monuments, heavy bearing load bearing structures or C type of retaining walls. At the same time, for the basalt, the profile of basalt is extremely high density with maximum bearing strength, which is most useful to construct the railway ballast, highway flexible bitumen base course and cobblestones likewise. Third one will be the limestone, where profile is weaker but possesses easily healed fracture, which is most useful for the Portland cement manufacturing, dimension stone, or we can say that the chemical fluids in the chemical laboratories. So granite, basalt and limestone, three types of rocks which are industrially utilized with reference to its characteristics and usage. That granite which is having very high compressive strength and widely used for monuments like structures. Basalt is highly durable and commonly used in pavement construction or in retaining wall construction, whereas the limestone, which serves the principle of raw material for the Portland cement. So these three types of rocks which present the most important petrological resources supporting modern civil engineering infrastructure. Stay tuned guys. Happy learning.